Hello friends, this video on NEET atoms is brought to you by examfear.com. No more fear from exam. Question number 17. In the Bohr's model of hydrogen atom, the centripetal force is furnished by the Coulomb's attraction between the proton and the electron. If A0 is the radius of the ground state orbit, m is the mass and E is the charge on electron, epsilon naught is the vacuum permittivity, the speed of the electron is. Okay, now as per Bohr's model, it says that the centripetal force is furnished by the Coulomb attraction. So what is the centripetal force? It is mv square by r and it is balanced by the Coulomb attraction. And Coulomb attraction is 1 by epsilon naught q1 into q2. So charge on the proton is E, charge on the electron is E, divided by the square of the distance between the proton and the electron. Now, distance between the proton and the electron would be the radius of the ground state orbit. That's because if this is the nucleus and if this is the electron, so this is the ground state orbit. So basically distance between proton and electron would be the radius. So this would be A0 square, right? So now this can be written as, so here also this r, that is the radius of the orbit, is nothing but A0. So this A0 and this will get cancelled. So we can say V square is equal to 1 by 4 pi epsilon naught E square divided by A0 m. So therefore V is equal to E divided by root over 4 pi epsilon naught A0 m. So the correct option is C. Question number 18. The radius of hydrogen atom in its ground state is 5.3 into 10 to the power minus 11 meters. After collision with an electron, it is found to have a radius of 21.2 into 10 to the power minus 11 meters. What is the principal quantum number n of the final state of the atom? Okay, so in this case, how do we find out the radius, or you can say Bohr radius in an nth orbit? So the radius is proportional to n square by z. So if you look at the expression for radius in the nth orbit, it is n square h square divided by 4 pi square m k e square z. So everything else is constant, so we can say radius is proportional to n square by z. Therefore, we can say r1 by r2 is equal to n1 square by n2 square, because z is equal to 1 in this case. We are only talking about hydrogen atom. So therefore, n2 square will be equal to n1 square into r2 by r1. So what is the value of r2? r2 is 21.2 into 10 to the power minus 11, and r1 is 5.3 into 10 to the power minus 11. So this 10 to the power minus 11 get cancelled. Therefore, n2 square is equal to 4, and therefore n2 is equal to 2. So the correct option is 2. Question number 19. In Rutherford scattering experiment, what will be the correct angle for alpha scattering for an impact parameter B is equal to 0? Now, even before we start solving the question, let us first quickly recap what do we mean by impact parameter. So, impact parameter is the perpendicular distance of the velocity vector of alpha particle from the central line of nucleus of the atom. Now, in the Rutherford's experiment, if this is the nucleus and if this is the atom and if this is the nucleus, so this is how the alpha particles were directed, and most of them got deflected. Some of them retraced their path, that is they got deflected by 180 degrees, and a lot others got deflected by smaller angles. So that's what basically happened in that experiment. So when we talk about impact parameter, which is denoted by B, it is given by 1 by 4 pi epsilon naught into z e square cot theta by 2, this divided by kinetic energy, right? Now, as per the question, B should be equal to 0, so this entire thing should be equal to 0. So for this entire thing to be equal to 0, cot theta by 2 should be equal to 0. Now we know that cot 90 degree is equal to 0. Therefore, we can say theta by 2 is equal to 90 degree or theta is equal to 180 degree. So D is the right option. Question number 20. Energy levels A, B, C of a certain atom correspond to increasing values of energy. That is EA less than EB less than EC. If lambda 1, lambda 2, lambda 3 are the wavelengths of radiation corresponding to the transitions C to B, B to A and C to A respectively, which of the following relation is correct? Let us quickly draw a rough energy level diagram. So let's say these are the three energy levels A, B and C. Right? And here lambda 1 corresponds to the transition from C to B. So this is lambda 1. Again, transition from B to A is lambda 2 and transition from C to A, this is lambda 3. So these are the three possible wavelengths. Now looking at this diagram, we can say that the energy difference between C and A, this can be written as EC minus EA. This would be equal to HC by lambda 3 because corresponding to these two energy levels, the wavelength is lambda 3. Similarly, we can write EC minus EB is equal to HC divided by lambda 1 and we can also write EB minus EA is equal to HC divided by lambda 2. So these are the three equations that we can write very straightforward. Now what we do is we add these two equations. Now the moment we add these two equations, we get EC minus EA is equal to HC into 1 by lambda 1 plus 1 by lambda 2. So this is what we get. Now if you compare this with equation 1, now let's call this as equation 2. So if you compare equation 1 and 2, for the left hand side is same for both of them. Therefore we can equate the right hand side. So we can write HC by lambda 3 is equal to HC into 1 by lambda 1 plus 1 by lambda 2. So HC will get cancelled. Therefore, we can say 1 by lambda 3 is equal to 1 by lambda 1 plus 1 by lambda 2. Now, let us solve this further. So, we can say that lambda 1 plus lambda 2 divided by lambda 1 lambda 2. Or we can say lambda 3 is equal to lambda 1 lambda 2 divided by lambda 1 plus lambda 2. So, the correct option is B. Question number 22. A hydrogen atom in ground state absorbs 10.2 electron volt of energy. The orbital angular momentum of the electron is increased by. Okay. So, let us first try to understand the question coolly. So, let's say that let's roughly draw the energy levels. Let's say this is the ground state and the energy corresponding to it is E1. So this is N is equal to 1. Now let's say that this is some excited state. Let's call it N is equal to 2 and the energy level corresponding to this is E2. Now for an electron to jump from E1 to E2, it would need some additional energy of delta E. Right? So we know this part. Okay. Now the question says a hydrogen atom in ground state absorbs 10.2 electron volt of energy. So that means this is the additional energy that the electron has absorbed. So basically 10.2 electron volt is the value of delta E. Okay, perfect. And initially the atom was in ground state. That means ground state, which is E1, is equal to how much? At ground state, the energy is minus 13.6 electron volt. Now, can we calculate the value of the energy of the excited state? Of course, we can. E2 will be equal to E1 plus delta E because energy at the ground state plus the additional energy which was supplied to it. So, this would be equal to minus 13.6 plus 10.2, which comes out to be minus 3.4 electron volt. So, this would be the energy at the next level, that is E2. Now we also know that energy at the excited state is equal to E1 divided by N square. right? So that means energy at the higher level is lesser. It's E1 divided by n square. So from this we can calculate the value of n square as E1 by E2. So E1 is minus 13.6 and E2 is minus 3.4. So this comes out to be 4. Therefore n is equal to 2. So this was something which we had assumed initially, and here we have found out that actually this excited state E2 corresponds to n is equal to 2. So now we know the values of n1 and n2. So we have to find out the increase in orbital angular momentum, right? So now in the ground state, what would be the orbital angular momentum? So from Bohr's quantization postulate, we know that mvr is equal to nh by 2 pi, and this mvr is nothing but orbital angular momentum, that is L. Right? So the value of orbital angular momentum in the ground state would be n1h by 2 pi, and in the excited state it would be n2h divided by 2 pi. So if you talk about the increase in angular momentum, it would be the difference between these two. So this can be written as n2 minus n1 into h by 2 pi. So n2 minus n1 would be 2 minus 1, which is 1. This is equal to h by 2 pi. Value of h, which is Planck's constant, is 6.63 into 10 to the power minus 34 divided by 2 into 3.14, and this value comes out to be 1.05 into 10 to the power minus 34 joules second. So you see, this question was a very conceptual question. It wasn't difficult, but it's based on the concept. So you actually need to understand what the problem is trying to tell.
Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.